This is page 312, number 5. So for number 5, they give us that p is x squared plus y squared, where x minus y is equal to 40. Now we have to find the minimum value of p, which means that this is our primary equation. Our primary equation is in 2 variables, so we need to use our secondary equation to change that. So what I'm going to do is I'm going to say that x is equal to 40 plus y, which means that p is x squared, which is y plus 40 squared, plus y squared. Okay, so p would be y squared plus 80y plus 1600 Okay, so the derivative of p is 4y plus 80. To find the critical numbers, we set our derivative equal to 0, and y turns out to be negative 20. But we need to justify that. We need to use the first derivative test or the second derivative test. The second derivative test is kind of nice here because the second derivative is constant at 4, which means that the second derivative at negative 20 is always 4, which is positive. So since the first derivative is 0 and the second derivative is positive, p of negative 20 is our minimum. Now we're not done because we actually have to find the minimum value of p, and we know that p is x squared plus y squared. Well, we found our y. We know that that's negative 20, and we know that x is equal to 40 plus y. So if x is equal to 40 plus y, then x must be 40 plus negative 20, which is 20. So let's plug that 20 in. And p is 800. So rewrite the minimum. P is 800.